Here's our third set of video notes. We went from 2.1 to 2.2, and we've skipped the rest of Chapter 2 and jumped to 3.1. So we're in Chapter 3, Section 1, and it's called Open Sentences in Two Variables. What sounds really complicated, but we've been solving open sentences or equations in one variable. So all our answers looked like this: x is equal to 3, right? If we have two variables, it means we have an x in the equation and a y in the equation. And so that means our final answer is actually going to be a point. So x will go in that spot and y will go in that spot. So we're having to solve for two. So just to kind of give you an idea, here's our first example. Give you a moment to write it down, or you can pause the video. We're going to solve this equation, 3x plus, or no, just kidding, 2x plus 3y equals 7. If the domain, and domain is x, if the domain is -1, 0, and 2. I want to figure out what my y's that correspond with are. So this sounds complicated, but I think you'll catch on really quick once I do a problem. So I'm going to write our equation, 2x plus 3y equals 7. It says if our domain, x, is -1, that's the first thing. So instead of writing x, I'm going to plug in -1, and I'm going to use that to figure out what y would be. 2 times -1 is -2. I'm going to add 2 to both sides. Divide, y is 3. So the answer to this one, when x was -1, y was 3, the point -1, 3. Next we're going to do the same thing. So I'm going to take 2x plus 3y equals 7. But this time, the second number it gives me for the domain is 0. So that's what I'm going to plug in. Two times 0 is 0, which just leaves me 3y is equal to 7. Divide both sides by 3. I'm just going to leave that 7 over 3. If you want to use the decimal, you can. I'll do that real quick. What's 7 divided by 3? 2.33333333. That's fine too. So when I plugged in 0, I got out 7/3, or 2.333333. Last but not least would be if I plugged 2 in. I almost don't have room. 2 times 2 is 4. Subtract 4. 3y is equal to 3. I'm going to divide both sides by 3, and y is equal to 1. So this point would be 2, 1. So that's kind of the vibe of what we're doing, but your homework's a little bit more complicated than this. This problem gave you a domain, but your homework's going to look like this. You have to solve the open sentence, so it's always going to be something like this. If each variable represents a positive integer, and b, a whole number. So I need to talk about the difference between a positive integer and a whole number. A positive integer, so a positive integer is positive integers. That includes 1, 2, 3, 4, and so on, forever and ever and ever until positive infinity. The difference between positive integers and whole numbers is whole numbers actually include 0. But positive integers do not. So we're going to figure out all the points that make this statement true, knowing that each variable has to be a positive integer. So I'm always just going to start with my smallest positive integer to see if it works. So I'm going to take 3x plus y is equal to 9. My smallest positive integer is 1, so that's what I'm going to plug into my equation first. 3 plus y equals 9. So in this case, y is equal to 6. So this point works. This is one possible answer to this problem. Let's try the next positive integer, which is 2. 3 times 2 is 6. That's equal to. I subtract, and y is equal to 3. So that's another answer to this particular problem, would be 2, 3. Let's try 3. When I plug 3 in, 3 times 3 is 9, plus y, which equals 9. I subtract, y is equal to 0. Now, this is where you're like, uh-oh. Okay, when we're talking about positive integers, that did not include 0. However, I just solved this equation and got 0. That means the answers, when you're only including positive integers, are only these two. There's only 2 answers when it asks for the positive integers. Because when I plugged 3 into this equation, I did not get out a positive integer. So if it says what are the answers when it's a positive integer, it's just these 2. However, the second half of this problem says what are the answers if we're including whole numbers? Well, that would include 1, 6, that's a whole number. Those are both whole numbers. 2, 3, those are both whole numbers. And then this answer would be included in whole numbers, 3, 0. Those are all whole numbers. But what happens if I plug 4 into this? Because you're like, well, why can't we keep going? 1 worked, 2 worked, 3 works for whole numbers. What happens if I plug 4 in? Okay, 3 times 4 is 12. When I subtract, I get y is equal to a negative 3. I have a negative number. Negative is not a positive integer, and it is not a whole number. So as I continue to get bigger and bigger and bigger, numbers are not going to work. If 4 doesn't work, 5 is not going to work, 6 is not going to work, 7 is not going to work, etc. So the answer to part A, positive integers, are these guys, 1, 6, and 2, 3. And the answers to part B about the whole numbers are 1, 6, 2, 3, and 3, 0. So you're going to have multiple answers for all of these problems. We're going to do a warm-up in class to make sure we understand this together, and then I'll give you your homework, and it's going to be a worksheet, less than 10 problems. You're welcome.